Students, we are discussing mineral nutrition. What is mineral nutrition? Now listen here. Note number 1. Boron deficiency causes a stout axis. Boron deficiency. What's that? Boron deficiency. Boron deficiency causes what's a stout axis. Boron deficiency causes what's a stout axis. Boron deficiency causes stout axis. Okay. Number 2, go for the second one. Aerophonics. 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 Sir, what is the meaning of this aerophonics, sir? Name itself indicates aero means air. Yes or no? It means this is also a soil-less culture. Aerophonics, it is also a soil-less culture. Okay, aerophonics is also a soil-less culture where the roots of a plant are suspended in the air. Roots of a plant, where they are suspended in the air. Okay, over the nutrient solution. Over what, sir? Nutrient solution. Over the nutrient solution. Sir, what is this one, sir? This is nothing but a nutrient solution. What it is? A nutrient solution. Sir, plants are not in direct contact with the nutrient solution, sir. Then how these plants will get this nutrient solution, sir? Listen. Sir, in this chamber, a rotor is present. What is present in this chamber? A rotor is present. Rotor. What this rotor will do means it will rotate in this nutrient solution. When this rotor rotates in the nutrient solution, then this nutrient solution is converted into mist, M-I-S-T, mist, small drops. Okay, this is nothing but a mist of the nutrient solution. Nothing but a nutrient solution, mist. What it is? A nutrient solution mist. Automatically, from this mist of nutrient solution, the roots will absorb the nutrients. Is this statement okay? Sir, we are discussing what's aerophonics. Sir, aerophonics is a soil-less culture. It is a soil-less culture. Okay, sir, what is happening in this aerophonics? What we are doing in this aerophonics, sir? Roots of a plant are suspended. Where? Are suspended in air. Are suspended in air over what? Nutrient solution. Over nutrient solution. Is this statement okay? Roots of a plant, where they are suspended in the air above the nutrient solution. Okay, then how these roots of the plant getting the nutrient solution, sir? Sir, this rotor, when rotates in the nutrient solution, it converts this nutrient solution into a mist. This mist is with what? Nutrient solution. From this mist of nutrient solution, the roots of the plant absorbs the nutrients. Okay, right? Number 3, we are discussing some important statements in note. Okay, right? Now listen this statement. Sir, most of the minerals present in the soil, most of the minerals present in the soil enters the plant through roots. Most of the what? Minerals. Most of the minerals present in soil enters the plant through enters the plant through what, sir? Roots. It means root is going to absorb the minerals present in the soil. Okay. Therefore, most of the what? Minerals present in soil, they enters the plant through what, sir? Roots. Is this statement okay? Right. Now listen this statement. Sir, in some plant species, right, selenium was accumulated. And in some plant species, the gold was accumulated. In some plant species, selenium is accumulated and even gold is accumulated in some plant species, right? In some what? Plant species. In some plant species, right? What gets accumulated, sir? In some plant species, selenium is accumulated and in some plant species, gold gets accumulated. Is this statement okay? Sir, the plants which grows near the nuclear test areas, sir, after discovery of nuclear weapons, after constructing a nuclear weapons, right, these nuclear weapons are tested. Okay, sir, nuclear weapons generally they contains radioactive elements. Nuclear weapons, they contains what, sir? Radioactive elements. When these nuclear weapons are used, that radioactive elements, they will go and settle in the soil. They enters into the soil and gets settled. Which elements? Radioactive elements. Plants which grows in these nuclear test areas, in such plants, radioactive strontium was accumulated. What was accumulated, sir? Radioactive strontium was accumulated. Radioactive strontium was accumulated. Therefore, plants which grows near what? Near nuclear test areas. Plants which grows near nuclear test areas, in such plants, radioactive strontium. What it is? Radioactive strontium. Radioactive strontium was accumulated. What was accumulated? Radioactive strontium was accumulated. I am not speaking about gold, I am not speaking about selenium, I am speaking about what's a radioactive strontium. Sir, plants which grows near nuclear test areas, in such plants, what was accumulated? Radioactive strontium was accumulated. Radioactive strontium was accumulated, right? Now, we are discussing some important statements in note, right? Now go for the fourth one, number 4, right? Now listen here. Sir, techniques. What, sir? Techniques which can detect. Techniques which can detect very low concentration of elements. Techniques which can detect very low concentration of elements are available. Okay, so we are saying that techniques which can detect very low concentration of elements are available. To what concentration a technique can detect elements in a plant, sir? 10 to the power of minus 8 grams per ml. How much, sir? Right, 10 to the power of minus 8 gram per ml. To this concentration of elements, we are having techniques right, that can detect this concentration of up to this concentration of elements in a plant. Up to this concentration of elements right, in a plant can be detected by using techniques. Okay, right? Go for the next topic. What it is? Deficiency symptoms of essential elements. Deficiency symptoms of essential elements. It means if essential elements are deficient, what are the symptoms that are shown by a plant? Okay, now listen the statements. Sir, when the supply of essential elements is limited, the plant growth is retarded. Yes or no? Because essential elements, they are required for growth and development of the plant. Essential elements, they are required for growth and development of the plant. Yes or no? So if the supply of essential elements is limited, automatically the plant growth is retarded. The plant growth is retarded, right? So when supply of what? Essential elements. When supply of essential elements is limited, supply of essential elements is limited, plant growth is retarded. Plant growth is what's sir? Retarded. Plant growth is retarded. Sir, when plant growth is retarded, sir, when the supply of essential elements is limited, when supply of essential elements is limited, the plant growth is retarded. Okay. Sir, the concentration of essential elements below which the plant growth is retarded, called as critical concentration. What is that concentration called as? Critical concentration. Sir, the concentration of essential elements below which plant growth is retarded, that concentration is called as a critical concentration. What it is called as? Critical concentration. Therefore, concentration of what? Concentration of essential elements. Concentration of essential elements below which, what happens? Below which plant growth is retarded. Plant growth is retarded. Okay. Sir, concentration of essential elements below which plant growth is retarded. What is that concentration called as? What is that concentration called as? Critical concentration. What is that concentration called as? Critical concentration. It means below the critical concentration, right? If a essential element is provided, the plant growth will be retarded. Yes or no? Right. Therefore, sir, concentration of an essential element below which the plant growth is retarded. What is that concentration called as? A critical concentration. Is this statement okay? Right. Now listen this statement. Sir, when we are going to say an element is deficient, sir, when we are saying that this element is deficient, if its concentration is below the critical concentration, yes or no, then we are going to say that the element is deficient. Therefore, element is said to be deficient if its concentration is below the critical concentration. If its concentration is below the critical concentration, right? Therefore, element is said to be deficient. Element is right. Element is said to be what, sir? Deficient element. Element is said to be which element? Deficient element. Element is said to be deficient element if its concentration is below the what? Critical concentration. Below the critical concentration. If the concentration of an essential element is below the critical concentration, then we are going to say that that element is a deficient element. Which elements are deficient element? Sir, what is the meaning of essential element? Required for growth and development of the plant. It means the essential element is having morphological, yes or no, morphological activities, functional activities, physiological activities in a plant. Sir, a essential element is having one or more than one morphological, physiological activities in a plant. If a essential element becomes deficient, automatically that morphological activity performed by the essential element will be affected, yes or no? Then automatically plant shows some morphological changes. Plant shows some morphological changes. Sir, why plant is showing some morphological changes? Due to deficiency of an essential element. These morphological changes which are due to deficiency of an essential element, that morphological changes are called as deficiency symptoms. Or that morphological changes shown by a plant due to the deficiency of an essential element called as deficiency symptoms. They are called as what, sir? Deficiency symptoms. Okay. Therefore, each and every what? Essential element. Each and every essential element has what? One or more than one or more than one morphological or physiological, nothing but functional, physiological activities in a plant. So, if an essential element, becomes what? Deficient. If an essential element becomes deficient, what happens? Plant shows some, plant shows some morphological changes. See this statement once. Sir, each and every essential element is having a morphological role or functional role in plant. So if an essential element becomes deficient, what happens? That role will be affected. So automatically plant shows some morphological changes when an essential element becomes deficient. Sir, these morphological changes which arise due to deficiency of an essential element called as deficiency symptoms. Okay, right? This morphological changes, this what? Morphological changes. This morphological changes that arised due to what? Deficiency of an essential element. Yes or no? Due to deficiency of an essential element, some morphological changes arise. These morphological changes called as what? They are called as deficiency symptoms. What are these morphological changes called as deficiency symptoms? Deficiency symptoms. Okay, therefore morphological changes that arise due to deficiency of an essential element, what are the morphological changes called as deficiency symptoms? Deficiency symptoms. Okay, this deficiency symptoms varies from plant to plant. deficiency symptoms, they varies from plant to plant, right? Deficiency symptoms. Deficiency symptoms, are they same in all plants? No, deficiency symptoms varies from plant to plant. Deficiency symptoms varies from plant to plant. What varies from plant to plant? Deficiency symptoms varies from plant to plant. Sir, how we can remove these deficiency symptoms? First you tell me. What is the reason how these deficiency symptoms arise? Due to the deficiency of an essential element. If the deficient essential element is supplied, the deficiency symptoms can be removed. If the deficient element is supplied, then deficiency symptoms can be removed. Sir, if deficient element is not supplied, it means if deficiency of an essential element continues for long period of time, it may even leads to death of the plant. If the deficiency of an essential element leads to deficiency of an essential element continues for long period of time, it may even lead to death of the plant, even leads to death of the plant, right? Therefore, deficiency symptoms. What's a deficiency symptoms can be removed. Deficiency symptoms can be removed. How? By supplying what? Deficient element. By supplying deficient element. Supplying deficient element, deficiency symptoms can be removed. Deficiency symptoms can be removed. If deficiency of an essential element, if deficiency of an what? Essential element. If deficiency of an essential element continues for long period of time, for long period of what's a time, then it may leads to what's a death of the plant. It may leads to death of the plant. Sir, what may lead to the death of the plant, sir? If deficiency of an essential element continues for long period of time, it means the element is deficient in the plant for long period of time. Then what happens, sir? It leads to death of the plant. It may lead to death of the plant. Okay. Now listen this statement. Part of the plant which shows deficiency symptoms depends on mobility of the essential element. Sir, which part of the plant shows the deficiency symptoms? The part of the plant that shows deficiency symptoms, it depends on mobility of the essential elements. Mobility of the essential elements, right? Part of a plant. Part of a plant which shows a part of a plant which shows what's a deficiency symptoms. It means which part of the plant is showing the deficiency symptoms. Depends on mobility. Depends on mobility of essential elements. Depends on mobility of what's essential elements. Sir, which part of the plant is showing the deficiency symptoms? That depends on what's mobility of the essential elements. Mean explanation for this statement. Listen. Sir, essential elements. If essential elements are remobilized, if essential elements are remobilized, if what? essential elements, if essential elements are remobilized, if essential elements are remobilized, then what happens? Then deficiency symptoms, deficiency symptoms first shown by older senescent leaves or parts. See this statement once. Sir, take a essential element, sir. If this essential element is remobilized, then who is showing the deficiency symptoms first? Older parts of a plant. That is, parts of a plant which are undergoing senescence. Parts of a plant which are undergoing what, sir? Senescence. Sir, essential elements are remobilized here, we are saying. Yes or no? Right? Nitrogen, phosphorus, potassium. Okay, NPK, nitrogen, phosphorus, potassium. Right? These are essential elements which are remobilized. Therefore, deficiency of nitrogen, phosphorus, potassium, okay, first appears in what, sir? First appears in older parts of a plant. It means parts of a plant that are undergoing what, sir? Senescence. Okay, right? As nitrogen, phosphorus, potassium are remobilized, or what, sir? Remobilized, their deficiency first appears in older parts of a plant. Therefore, which part of the plant is affected first? Older parts of a plant is affected if essential elements are remobilized. Okay. Now go for the second case. If essential elements are not readily remobilized, not readily remobilized. Sir, why here essential elements are not readily remobilized, sir? Take calcium. Calcium is a structural component of a cell. So it won't be remobilized easily. It is not readily remobilized. Who, sir? Calcium. In such cases, the deficiency symptoms are first shown by younger parts of a plant, but not older parts of a plant. Okay. Therefore, if essential elements are not readily remobilized, what happens, sir? Then deficiency symptoms. Right? First shown by which parts of a plant, sir? Younger parts of a plant. Deficiency symptoms first shown by younger parts of a plant. Right? Sir, as calcium, what, sir? As calcium, macro, right? Macro element. As calcium is a what? It is a structural component. As calcium is a structural component of cell, it is not readily remobilized. Who is not readily remobilized? Calcium is not readily remobilized. Why? As it is a structural component of the cell. So, deficiency of calcium, it means if calcium becomes deficient. So, deficiency of calcium. So, deficiency of what, sir? Calcium shows deficiency symptoms. Shows what, sir? Deficiency symptoms. Shows deficiency symptoms. First, in which parts of a plant? younger parts of a plant. So deficiency symptoms are right first shown in younger parts of a plant. First shown in younger parts of a plant, right? Now listen here. Sir, what are the deficiency symptoms shown by a plant when an essential element is deficient? Okay, right? What? Deficiency symptoms. Deficiency symptoms are shown by a plant when an essential element is deficient. Sir, when essential element is deficient, what are the deficiency symptoms shown by a plant? Number 1, chlorosis. What is the first one? Chlorosis. Number 2, necrosis. What is the second one, sir? Necrosis. Third one is inhibition of cell division. What is the third one, sir? Inhibition of cell division. Inhibition of cell division. Number 4, stunted plant growth. Stunted plant growth. Stunted plant growth. Okay. Number 5, premature leaf and bud fall. It means premature falling of leaves and buds. Next, number 6, delay of flowering. What is the sixth one? Delay of flowering. See the statements once. Sir, when an essential element is deficient, these are the deficiency symptoms shown by a plant. What are they? Chlorosis, loss of chlorophyll. If chlorophyll is lost, the leaf becomes yellow. Yellowing of leaf due to the loss of chlorophyll is called as chlorosis. Sir, chlorosis is not only caused by the deficiency of essential element, it is also caused by viral infection. It is also caused by viral infection. Okay. Therefore, chlorosis caused by deficiency of essential element, even caused by viral infection. What is the meaning of chlorosis? Loss of chlorophyll. If chlorophyll is lost, leaf becomes yellow. Yellowing of leaf. Now go for the second one. Necrosis. Necrosis means death of tissues. Tissue death, particularly death of leaf tissues. Particularly leaf tissues, death of leaf tissues. Next, inhibition of cell division. Stunted, reduced plant growth. Premature, it means before reaching maturity, leaves and buds are going to fall off. What is delayed? Flowering is delayed. Now, once you see this chart, sir, chlorosis is a deficiency symptom. When this chlorosis arises, if nitrogen or potassium or magnesium or sulfur or manganese or iron or molybdenum or zinc becomes deficient, it means when these elements becomes deficient, you are going to see chlorosis as a deficiency symptom. Sir, if calcium, magnesium, potassium, right, sulfur becomes okay, copper becomes deficient, right, you are going to see necrosis. Therefore, necrosis is a deficiency symptom shown by a plant when plant becomes deficient in calcium, magnesium, potassium, copper. Sir, inhibition of cell division. This is due to the deficiency of nitrogen, sulfur, right, potassium, molybdenum. When these elements, if any one of these elements becomes deficient, cell division is inhibited. So, delay of flowering, it is due to deficiency of either nitrogen or sulfur or molybdenum. You should be very careful. Sir, nitrogen, right, potassium, magnesium, sulfur, these are macro elements, whereas manganese, iron, molybdenum, zinc are micro elements. Sir, calcium, right, magnesium, potassium, macro elements, copper, micro element. nitrogen, sulfur, what? Potassium, macro, molybdenum, micro. Nitrogen, sulfur, macro, molybdenum, micro. Yes or no? Therefore, you should be careful which one is macro element and which one is micro element. See this chart once. Sir, if nitrogen becomes deficient, plant not only causes chlorosis, not only shows chlorosis, but also shows inhibition of cell division and delay of flowering. Therefore, deficiency of nitrogen not only leads to chlorosis, but also to the inhibition of cell division and delay of flowering. Therefore, deficiency of an essential element causes multiple symptoms. It means if one element is deficient, it causes more than one deficiency symptom. If magnesium is deficient, you can see chlorosis. You can see necrosis also. Therefore, deficiency of an essential element causes multiple symptoms. It means if one element is deficient, more than one deficiency symptom can be seen. Right? Thank you.